Okay, so we're going to be looking at some questions to prepare for your test on linear equations, solving systems of simultaneous equations, linear relationships, and functions. So starting with number 1, we have a mapping between these x values and the y values, or the f of x values. So we can see that negative 1 has got an output of negative 4 when we put it into this function. And so we have to use the mapping diagram to write down two equations in terms of a and b. So let's start by using, say, this first value of x. If I substitute it into this equation, I can see that f of negative 1, if I substitute in the x, would be a times negative 1 squared plus b times negative 1. Now we know that f of negative 1 is equal to negative 4. That's the mapping value. So negative 4 is equal to a times, well, negative 1 squared is 1. And then this is plus b times negative 1. So let's just leave it like that for now. And if I rearrange this equation, then I can put the negative 4 on the right-hand side, and I can put this stuff all on the left-hand side. I've got 1a, and I've got negative 1b. Alright, that's my first equation. Let's now figure out a second equation by using the x value of 1. And so I'll just indicate this. This is my first equation right here. Okay, so f of 1 is equal to a times 1 squared plus b times 1. And so I know that f of 1 is equal to 8, because that's what 1 mapped to. And a times 1 plus b times 1. Now again, let's just put these in reverse order, because it's nice for when I use poly-simult to solve a system of simultaneous equations to have my variables on the left. And so my resulting equation, I'll have 1a plus 1b is equal to 8. And these are my two equations, so I've solved part A of the problem. And I also need to find the value of a and b. This is where I can use poly-simult. So I'll go into my apps, and I'll choose poly-simult. And let's just scroll down. You can see I've got all of these extra apps I shouldn't have. Please make sure that your calculator has got only poly-simult, finance, and catalog help on it. Alright, so poly-simult 2, and I'm going to go into simultaneous equation solver. And I've got two equations with two unknowns. So let's say next. And I'll put in my first equation. I can see that my values are 1, negative 1, and negative 4. So 1, negative 1, and negative 4. Oops. 4. And my second equation, I've got positive 1a, positive 1b, and positive 8. And once I've entered these numbers into the system matrix, I'll press this solve button right here, and it will tell me that my first variable, which in our case is a, is equal to 2, and b is equal to 6. And no work is required. IB does not expect you to show any work when you're solving systems of equations. They want you to use poly-simult. Alright, let's work on number 2. See that a and b are points on a straight line? We need to write down the y-intercept of the line AB. Well, it's pretty apparent that we intersect the y-axis at a value of 6. And so our y-intercept is going to be 6. We could say y equals 6, or we can even write it as a coordinate. Either one would be fine. Part B, calculate the gradient. That's another word for slope, and we know that slope can be found by taking the difference between the y-coordinates divided by the difference between the x-coordinates. And so the y-coordinates, we've got 5 minus 2, and the x-coordinates, we've got 2 minus 8. That simplifies to give 3 over negative 6, or negative 1/2, and that's our gradient. Let's move on now to number 3. This diagram shows two lines, L1 and L2, and they're perpendicular to each other. That's important because it means that the slope of L1 is perpendicular to the slope of L2. They are going to be negative reciprocals of one another. Now it says to calculate the gradient of line L1. Well, in line L1, I've only got 1 point, so I can't calculate its gradient yet. But I could calculate the gradient of line L2 and then take the negative reciprocal of that line, because I know that line 1 is perpendicular. So why don't we do that? I'm going to calculate the slope of line 2, and so it's going to be the difference in the y-coordinates, -2 minus 0, divided by the difference in the x-coordinates, 0 minus 5. Just make sure you maintain the same order. If I did this point minus this point for the y's, I must do this point minus this point for the x's. And please remember the y's go on the top, the x's go on the bottom. This gives me -2 over -5, or if the negatives cancel out, I get 2/5. And so the slope of line 1 then must be the negative reciprocal, -5 over 2, and I've solved part A. Part B, we need to write the equation of line L1 in standard form, where the coefficients A, B, and D are integers, and A is greater than 0. Well, why don't we just start by finding out the equation of the line in slope-intercept form, because that's a bit more familiar for us. So we know that in y equals mx plus b, in our situation, our slope of line 1 is -5 over 2. Our x-coordinate, one of the things that is on line 1, in fact, even better, we've been given the y-intercept, so we can immediately see what the b value is. It's going to be +7. So we just need to convert this form of the linear equation into the required standard form, where a, b, and d are integers. If they're going to be integers, I have to multiply this equation through by something to get rid of this fraction. Let's multiply it through by 2. So I get 2y equals -5x plus 14. Remember, we have to multiply every term by 2. And now I'll bring everything to the left-hand side of the equation, because the required form has got a 0 on the right. So my -5x as it moves to the left becomes a +5x. I still have a +2y, and my +14 becomes a -14. And now I have solved the question. Moving on to number 4. For line L1, we've been given its equation in standard form, 3x plus 4y equals 24. And we're told that it cuts the x-axis with an x-intercept at A and a y-intercept at B. We need to write down the coordinates of A and B. Well, one thing we know about the x-intercept is that y is equal to 0. And at the y-intercept, we know that x is equal to 0. So let's substitute these values in turn into the equation. So let's start out by finding the coordinates of point A. I don't know what the x-coordinate is, but I do know that the y-coordinate is 0. And so 3x, this term becomes 0, doesn't it? So 3x equals 24, x equals 8. And that must mean then that point A has got the coordinates, because it's asking us for the coordinates here. So A has got coordinates 8, 0. Let's do the similar step. In this time, x is equal to 0 as we look for the coordinates of point B. I don't know what y is, but I'll quickly find it, because this term becomes 0. 4y is equal to 24, and that must mean that y equals 6. So that shows us that the coordinates of point B with the x value of 0 and y value of 6. It says then, M is the midpoint of the line segment AB. So M is right in between A and B. Now it says that the diagram is not drawn to scale, so don't worry about the fact that it doesn't look like it's the midpoint. You're told that it is, so it is. We need to find the midpoint of points A and B. We know that the midpoint can be found by taking the average of the x-coordinates and the average of the y-coordinates. And so let's put that, let's substitute in our known values. 8 plus 0 over 2. And my y-coordinate 0 plus 6 over 2. And that will show us that the midpoint has got coordinates 4, 3. Now the line L2 passes through our midpoint M, as well as this other point C. We need to write down its equation. Well, let's begin by finding the slope. Alright, we know that the slope is going to be the difference between the y-coordinates, so let's do this one first. 3 minus -2 divided by the difference in the x-coordinates, 4 minus 0. 3 minus -2 becomes 5, 4 minus 0 is 4, so that's our slope. Now in order to get the equation, let's think about it in terms of the form y equals mx plus b. It doesn't specify the form in which we must leave the equation, so let's use our easiest form, slope-intercept form. We know that our slope is 5 over 4. Now let's substitute in a known point. Do I need to do this? Yes, I do. Okay, so let's substitute in a known point on the line, such as our midpoint is clearly on the line, because line L2 does pass through that point M. So let's substitute in an x value of 4, and my y value is 3, and I need to solve for b. So 3 is equal to, well, these 4's will cancel, so it will be equal to 5 plus b, and that means that b is equal to -2. So therefore, the equation of the line, y equals 5 over 4x, and now we know the b value, -2. And lastly, part D, let's find the length of AC. So we need to find the distance, use the distance formula between point A and point C. Now your distance formula is the square root of the difference between the x-coordinate squared and the difference between the y-coordinate squared. In this case, our x-coordinate of A is 8, and the x-coordinate of C is 0. And so their difference is going to be 8 units. And then the difference between the y-coordinate, 0 minus -2. There we go. I'm going to have to kind of go on into the next page a little bit. And so our distance then is equal to the square root of, so this is 8 squared, 64. This is +2 all squared, which is 4. And we've got a final answer then of square root of 68. And we could work this out in the calculator if we wanted. So we could go, what is the square root of 68? And we'll get an answer of 8.25 when I round to 3 significant figures. Number 5. We've got this triangle ABC with the given points for C and the equation of line AB. We need to find the coordinates of A and B. Well, this is very much like the question that we just did, isn't it? We know that the value of the y-intercept will occur when x is 0. And so we'll quickly find out that y is equal to 4, and therefore the coordinates of A are 0, 4. And we can find out the coordinates of B by substituting, because that's an x-intercept, that means that now our y value is equal to 0. And so you quickly figure out that x is 8, so the coordinates of B are 8, 0. Alright, let's move on now to part B. We have to show that the distance between A and B is 8.94. So let's use the distance formula again. I'm going to do this a little bit quicker. So I'm going to take the difference between the x-coordinates. Clearly that's a distance of 8 units squared. And the difference between the y-coordinates between A and B is clearly 4 units. And so this is going to be the square root of 64 plus 16. That's the square root of 80. And let's figure out what the square root of 80 is. Square root of 80. And sure enough, to 3 significant figures, we do get 8.94. Now IB will normally want you to write the unrounded answer first. So 8.9442791, and then this rounds to 8.94 as required. N lines on the line AB. So here's point N lying on AB. The line CN is perpendicular. That must mean that its slope is a negative reciprocal. So let's find the gradient of CN. To do this, we're going to have to first find the slope between A and B. And so we know that that's going to be the difference in the x-coordinates. So our x-coordinates, we've got 0 minus, the difference in the y-coordinates, so 0 minus 4 over 8 minus 0. And that equals -4 over 8. And that equals -1/2. And the negative reciprocal is going to be +2 over 1. And I'll continue this problem in the next video.